said this. So pretty much every single recursive backtracking algorithm uses this algorithm, this solve algorithm. So we're going to see how this looks in the context of the 8 queens problem. What I will not do is solve this part for you. Okay. What I'm going to try to do is walk through here and show you how to set this up. Okay. It works the same for Sudoku. Okay. So, and again, normally I wouldn't do this, but it's 2020. And also, you know, there are things. So first off, how did I want you to store your board? And I'm going to make things static here. Appearance, presentation mode, settings. Anyone?
Double int array.
Sorry?
You can start in a double int array. Just
Yeah.
use zeros and ones.
Yep. So we just want to use zeros and ones. View. Exit presentation mode. View. Appearance. Enter presentation mode. There we go. Zeros and ones. So we're going to create a int array, a 2D array. And I'm going to call it the board. And I'm going to, actually, I don't need to create a static thing anywhere. I'm just going to do PSVM. I'm going to create a int board over here. It's equal to new. And actually, the hardest part for me writing these is always forgetting how do I initialize a 2D array. But I've done enough times that I can finally remember it. All right. And then we need a solve method, which is going to be pretty straightforward. Public static solve Boolean. It needs to return a Boolean. And then we need to take in the board that we're using, whatever so in other words, our puzzle surface. Okay. And then we need to take in a position. So that's the first step. Now in the PDF that I have, let's see. I suggest that, hint, only one queen can be placed in each column. That means we can simplify the problem by asking for this current column, what row can I put it on? So rather than so let's consider that from our perspective, right? We have a position, basically we have positions and we have choices, right? For a given position, we have a choice. So if we consider our column to be the position, then our choice is what row we're going to put it on, right? This is as opposed to the Sudoku problem where where the position would be the row and column, but the choice would be what you put in that row and column. Here, you're deciding whether to put a queen down in that particular row. There's not really that much choice for it. So int column. So we're going to go column by column. We're going to go left to right. We're going to go 0, right, to what? So we're going to go 0. So the valid columns would be column 0, column 1, column 2, column 3, column 4, and so on and so forth, right? Everybody following so far? Please let me know if you've gotten lost, because I don't want to lose anybody on this one. I want you to really understand this. Okay. So everybody's following? Great. Accept the terms of the license agreement. Welcome to Whiteboard. Like I said, I just reformatted this computer so that I could have access to the different, better access to my better organized hard disks. So let's go ahead and we're going to do ink to shape, ink to table. So, right, Yeah, I can't draw worth anything, but there we go. 1. And yeah, undo that. And then slice. Oh, nope. So apparently I needed, okay, now I know how this works. So this is a useful tool if you've, so this is a pretty useful tool, the whiteboard feature. Let's see. 4. 1, 2, 3. Let's see. So 1, 2, 3, 4, 5, 6. And then normally I'd bring an actual chessboard, but my chessboard has been stuck at, my poor chessboard is stuck at school. Okay, so we've got a board here, right? So now so what we're going to be doing is that basically our strategy as follows. Start at this space and put in a queen. Okay. Then what we're going to do is that we're going to look for this through this and go, can we put a queen here? No. What about here? No, because we're right next to the queen, queen can attack. Can we put a queen here? Sure we can. Okay. Can we put a queen here? Nope. Nope, because I'm going to be attacked by this queen. Nope. Nope. I'll put a queen here. What about here? Nope. Could put a queen here, so I'm going to do so. And basically, you're pretty greedy. You get pretty greedy about how you can do these things. Okay. Then it goes no, no, no. Okay. You go look for here, and it basically you go through all the possibilities of the rows. Now, say though that we get into a position like, let's go ahead and simplify this actually to a 4x4 board, shall we? Still learning how to control these things. Sorry. It worked getting rid of the other ones. So I don't know why it doesn't get rid of these. Oh, wait, hold on a second. I am being stupid, I think. Okay. Wow. Sorry. The issues with learning how to use a tool when you think you have an idea of how to use it. Alt text. No, no, no. I just want to, there we go. There we go. I hope you are highly amused by this as opposed to frustrated by this. Okay, so let's go ahead and look at the 4 queens problem, right? Where basically we have 4 queens. I can put a queen here. So let's go to the next column. I can put a queen here or here. Can't do that, right? But I can put a queen here. Okay, next I think, okay, can I put a queen here? No, can't put a queen there because I'm being attacked by that queen. Can't put a queen there, there, or there. So here we hit a dead end. In terms of our code, what we're going to be doing at that point is, right, for each possible choice, we didn't find any possible choices. So we have to return false. So what happened if this guy called this line of code over here, the if solve board position +1 is equal to true, right? We tried to solve this here. Everybody following so far? I'm not getting a lot of responses. Am I just speaking into a void?
I think it makes sense.
No, I'm good.
Okay. Yeah. Feel free to use the chat to give me feedback or whatever. So at that point, right, since we're still in the loop, since we are still in this loop of, right, that didn't work for that choice. So what we do is we clear this board. Okay, we clear this and we move on to the next one. Right? And then we try to go here, can't go there. We can go here, can't go there, can't go there, can't go there, can't go there. So we return false to this guy. So he goes, okay, I was here, so let me try the next spot. Can't go there, can't go there. Let me try. And so now we return false to him, who returns false to the very first one. Okay. And so the first one goes, can I put it here? And then so it starts over until we get actually to the end and we solve the problem. Now, at this point, what happens is that we're going to call, basically, we would call, okay, column plus 1. Well, there is no column plus 1. The only reason we're going to get out of bounds is if we solve the puzzle. So return true, which makes him return true to say, we solved the puzzle. You found the right spot. We found the puzzle. And this sends the signal to him saying, hey, you found the right spot. And that sends the signal to him saying, your spot is good. We solved the puzzle. So a return true is used to broadcast, we hit a solution. A return false is used to broadcast, we hit a dead end. Somebody up the chain needs to move. Okay. So that's what this does. So for right now, what I'm going to do is that I'm going to create a public static Boolean can place. And what this is going to do is that we're going to create an int. We're going to take in our board. We're going to take in an int row, int column. Always put your column before row, otherwise, because that's just the way it's expected to go. And that's it for all we need for this one. And all I'm going to do is say return true. You can put a queen anywhere you want. Right. And the reason I'm doing this is just so that I can get the recursion programmed in. Okay. So let's go ahead and try to do this one. So if I'm out of bounds, basically I hit the end of the puzzle. So if call is greater than, and let's go ahead and make this so that we can, I'm going to make this so that it is actually variable. Like, so it would work on a 4 queens or an 8 queens or a 12 queens puzzle. So if column is greater than or equal to board dot length, return true. Make sense? So if we get out, if we somehow hit out of bounds, we're done. Make sense to everybody? Otherwise, at the end, by default, we're going to return false. So now we need to say for every choice we have. So for, what is our choice? For int row is equal to 0. Row is less than board dot length. Row plus plus. Okay. So those are the various, so that's for every choice we have. We ask if can place board row column, right? That's our is valid method right there. If we could put a queen in this board and this row on the board at this row column combination, then we're going to put the queen there. And I'll just put in a 1 to represent a queen, because by default, I don't have to set it. By default, whenever you initialize a array of integers or a double array, it's going to be a bunch of zeros. It's always going to be the 0 value. So for Booleans, that would be false. For integers, that's 0. For floats, that's 0. And for everything and every object, that's a null. So here, board is equal to 1. And then we go on to the next thing, which is we can place that. So now we do our recursive call. We said we solved our column. That's all I care about. That's all I'm doing. Next, I need to say board. Now I say if solve. If our solution of this board, so if this position that we chose lets us solve the next position, if that reports back true, that means that the only way it's, so first off, if we get back false, that means that somewhere along the chain we hit a dead end. So so we'd have to adjust in that case. But if this call returns true, that means that the calls I've made, the recursive calls I've made, managed to make it all the way to the end, right? Column plus one, we called column plus one, and he called his column plus one, which called his column plus one, all the way until we got out of bounds and hit true. So in that case, I'm going to return true because we hit a solution. I can say that my solution, that my position works. But if it doesn't work, then I need to adjust. And in this case, over here, what I'm going to do is I'm going to pick up the queen, right? Oh, that spot didn't work. I'm going to pick up the queen. Make sense to everybody so far?
Yeah.
All right. So let's go ahead and run this code. See how this looks in presentation mode. Oh, right, got to call it, and then we got to print things. So let's go ahead and do that. So solve board 0. Okay, and now we're going to go ahead and then for int array row in row, sorry, row in board. So for each row in board, arrays dot toString that row. So that will just convert that into a nice, easy to read string. But before I do that, I have to actually put in this out. And now we do that. We run it. And that we got a bunch of ones across the edge. Now that makes sense because we've always been saying true. Makes sense? So let's go ahead and try a different combination. So return row is equal to column. So now I'm going to run that, and we'll see that we get a subtly different result. We get it going across the diagonals. And this is pretty easy to process. So here we're saying the rule is you can only put it down if the row and column are equal. So for 0, 0, that makes sense. So on this guy, so now for this guy, he'll try by putting his first queen down here and ask, can I place this here? No. Can I place it here? Yes. And so on and so forth. So this guy will place it down here, and then the next guy will try to place it here, here. There's going to be no backtracking involved in this one, because this is a fairly straightforward solution. But now essentially what you have to do is work on the can place. And you've got to but fortunately, it's not as terrible as it seems. Let's go ahead. Okay. It's not as terrible. The can place isn't as terrible as it seems. So let's take a look at this fabulous looking queen over here. Okay. So the queen can move in 8 directions, right? Makes sense to everybody? You can move vertically, horizontally, and across all 4 diagonals. So you're thinking to yourself, great, I have to make 8 checks when I place a queen at row column to make sure that I'm not going to be confronting another queen. Well, you don't have to make 8 checks. First off, we're enforcing that there's only one queen per column. So these are out. Don't have to bother checking those, right? And not only that, we are placing our queens from right to left. There will never be any queens that when I'm putting a queen down and trying to figure out where I'm going, there's never going to be any queens to the right of me. So that brings it down to 3 directions you have to check queens for. You have to check if there's a queen in this direction, a queen in the upper left diagonal, the lower left diagonal, and any queens to the left. I recommend trying to program this one first because that will get you this solution over here. It'll look like a diagonal, and then work on the other ones. Any questions on this one?
Could you post the code for the first program, for the solve program? I just wanted to look at it.
I will do it. What I'm going to do is I'm just going to, for simplicity's sake, is I'm going to just drop this into the chat. Okay. So ready, 3, 2, 1, hit enter, bam, boom, it's in the chat. Okay. Make sense? Okay. Now, the only thing I have to say with Sudoku is that basically one of my pet peeves for the solve method for Sudoku is that I get students who write something like this. Solve board and this is for Sudoku specifically. Turn false. And what they do is that basically they go through and they write a loop like this. For int row is equal to 0, row is less than board.length, row plus plus. Then they do the same thing over here where it's column, and then it's again board.length. What's going on over here? Cannot resolve symbol row?
The comma instead of a semicolon.
Oh. Okay. So programming too much in Python these days. All right. So, and then basically they say, and then they might say basically if, and then what they do is they say if row, if board, row, col equals 0. So they look for the first empty space like this. Okay. So you go through, you look across the top and you look for the first empty space in your Sudoku board. Don't do this. Because you should always know where you are. You should always be here for Sudoku. If you're solving Sudoku, you should always pass in the row and column to know where you are. And then ask yourself, what does the row being out of bounds mean? What does the column being out of bounds mean? What do those things mean? And should I wrap around to the next thing that I need to process? So that is the big thing there. For recursion, it's always about a local decision. You don't take a global view, and the for loop over there kind of violates that philosophy. You don't want to look for the empty row. The only for loop you should do is for your choices in that row and column. Everything else is a base case. All right, so with that, I'm going to stop the recording.